This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
So welcome everyone to the Software Engineering Radio today. My name's Kim Carter. I'll be your host for the day. And today we've got Natalie Silvanovich as guest. Natalie is a security engineer on the Google Project Zero team who reviews heavily used software for security problems. Natalie has discovered over 100 vulnerabilities in browsers, mobile devices, and security software. Welcome to the show, Natalie.
Great, thanks so much for inviting me.
So we've had shows on application security with Zane Lakey. That was show number 309. And we've had network security with Haroon Mir. That was show number 302. Today we're going to be discussing attack surface reduction. So I'm just going to start off with some pretty basic questions. Can you explain, Natalie, what attack surface actually is?
Every application, every piece of software has an attack surface. This is whatever an attacker can manipulate, the APIs of your web application or the files that your file format parser processes. Anything that an attacker can use and find bugs in is attack surface.
Yeah, so not just software.
Well, it usually is software, but when we talk about attack surface, it's really the features of the software, and in particular the ones that are available to an attacker in a way that is useful. To give an example, let's say you have a web application that also processes some local files on the server it runs on. The remote stuff that an attacker can reach is much more concerning attack surface than, say, the local stuff.
Why is that?
Well, you have to think about it from the attacker's perspective. If you're an attacker, usually you want to access data on a system or do something else unauthorized on a system, and depending on your vantage point, you have different options. So if you think about software that's accessible over the internet, there are tons and tons of attackers on the internet that could access it and use it to do something bad. So that's something to be concerned about. And then sometimes there are situations in software where if you think about who can change certain input, it's not someone who would want access to the system, or it's someone who already has access to the system. So that's why it's not a concern.
So if we are to reduce attack surface, we need to be able to measure it. How would you go about quantifying the attack surface before and after defects have been found and fixed?
Yeah, that's very difficult to do, and there's no metric where you can say, like, I have 5 attack surface or something like that. But I think what is the most important is just understanding the attack surface you have, actually going through your software or your application, whatever you're working on, and make sure you understand every feature that you have and how it can be accessed.
So how does your threat modeling approach take into consideration the severity as well as the number of defects?
Personally, I don't do a lot of threat modeling. My team, we're mostly interested in finding bugs that are used by malicious attackers. We call them zero-day bugs. And so we pick our targets based on how commonly zero-day vulnerabilities show up in a piece of software and how serious the problems are.
Yeah, okay. So I'm working on a project, for example. I've measured my attack surface. I've done some threat modeling, and I've found and fixed some defects. And then I've done some more threat modeling. So I've measured again. And the attack surface is now 10% smaller. Is my project now 10% more secure?
Maybe. These things are always difficult to measure, but I think that's usually not the case, because usually some parts of software are far more prone to threats than other parts of software. And this is really what I'm talking about quite often when I'm talking about attack surface reduction. Because every feature that software has is useful for something to users, hopefully, and then it has a risk to users. And it's kind of important that those are in line. If you have a feature that is not used very often, but is very high risk and has tons of defects in it and that sort of thing, that's something you need to get rid of. Meanwhile, sometimes things can be high risk, but if they're very useful, then that's not a feasible thing to do. So yeah, just, removing 10% of your code, there's no guarantee that that's going to remove 10% of your problems. Almost everyone's code base, they probably have one thing they could remove that would reduce far more problems than the percentage of code it makes up.
Yeah, right. So you mentioned in your Small is Beautiful talk that we should base features on user need. We should track features use in beta or production and be willing and able to disable features. So I think this is pretty good advice. Is this assuming we have 0 users consuming this specific feature?
No, it's not. And it really depends where you are in the dev process, which is part of why I went around giving that talk, because, once users are using a feature, it becomes a lot more difficult to remove or even change the attack surface of. So, of course, the easiest thing is before a feature comes out to think about whether it's useful to users and specifically think about the risk it poses and whether maybe there's other ways to provide that benefit without having the same risk. And then once you get into the point where you have the feature in, that's where maybe you don't have as many options. And you can remove a feature if users are still using it. There's several examples, situations where vendors have done that. For example, Microsoft has disabled several features. For example, certain parsers in their document programs. But that's always going to turn off a certain number of users. So that's something which is often only possible if something is really obsolete and not under that much usage.
You also mentioned that all code has a risk and that adding a feature is a trade-off. I usually go a bit further than this and say that all features are trade-offs, including physical, people, VPSs, networks, cloud, mobile, and IoT. And we need to be considering the attack surface of everything. Can you apply the previous question and answer to all of these areas? And if so, how?
Yeah, I'm not sure how much guidance I can provide on that because I mostly look at software. But I think it is true that when you add a feature to software, you need to consider the full cost of it. So I always have security on my brain, so I'm thinking about the security cost. But it is true about, people, hardware, everything else. Every feature has a cost, and it's fairly common for people not to consider the full cost of doing things before they do it. Actually, one of the examples I give in my talk is branching and different types of build systems. It's fairly common for companies to start creating new versions of software or branching or creating new SKUs if it's a physical product without fully understanding the cost, including the security cost. And then that can lead to problems later when they discover they have to push updates to everything.
Yeah, we're going to get into branching and that sort of thing a little bit later on too. So we're just going to move into a small section on software engineers and their current state in terms of attack surface reduction. Can you explain how you are significantly reducing the number of people harmed by targeted attacks? When any number of the bugs that the Project Zero team, for example, identifies appear to be completely swamped by the continual onslaught that developers continue to be creating in just about everything produced.
Yeah, well, we certainly hope that is not the case. This is true that some products do have the problem where there are certain components where the rate at which they add bugs is so fast that it becomes difficult to fix them because new bugs are just being added. But I would hope that a lot of the stuff we look at is mature enough that this isn't the case. And I think we've seen evidence of this in that when we found security bugs, sometimes other people, even malicious attackers, are discovered to be using the same bugs. And we call that bug collision, which means that we're causing a bug that's actively being used to be fixed. And this happens enough that we do think that we are finding the same bugs as attackers, and getting them fixed does have an impact.
Yeah. I think it's because you're focusing on the most heavily used software. Would you say that would be correct?
Yeah, that's definitely true. Since the software we look at is so heavily used, bugs in it are fairly sparse, and that's why this approach is useful.
So there was a post on the NPM blog recently called Attitudes to Security in the JavaScript Community. So in this post, there was 87% of respondents said they were concerned with the security of the code they wrote themselves, compared to only 77% saying the same about the open source libraries that they were consuming. This to me sounds like a wake-up call for the security community that we've been waiting for years, and it's actually starting to happen. What are your thoughts on these statistics? Do they sound realistic? And are you noticing a similar trend in developers taking security more seriously?
Yeah, I think that's true. Most developers I do meet are fairly concerned about security, and I think that's really a positive thing. But I think being concerned about security isn't enough. The companies that develop software need to make sure that they're giving developers adequate resources to develop secure software, and that everyone's making it a priority. So I have noticed, especially when giving this attack surface talk, that there sometimes is a bit of a difference between what developers want to do and what they end up doing, considering the realities of the software they develop. But I do think it's very positive that security is at least on the mind of a lot of developers.
What's your experience and or thoughts on where the level of security defects are in JavaScript compared to other languages and their environments? And what are your thoughts on these statistics and how we can continue to improve them?
Yes, that's a bit of a complicated question. So when you're talking about JavaScript security, you can mean a lot of things. And when I say I look at JavaScript security, I'm looking at the security of JavaScript engines. So this is, you visit a web page using Chrome or Edge or Safari, and then that web page causes memory corruption in the browser, and then the browser can execute malicious code on your system. So most of that code is actually written in C++, although some of it is written in JavaScript these days. Meanwhile, there is the other side of this, which is vulnerabilities in code that is actually written in JavaScript. And I would say we see less of these publicly, and I think there's two reasons. One, just because of the nature of where JavaScript is used, it's less likely these end up getting known publicly because people just fix their own websites. And I think there's also more fragmentation, more individual web pages that are small that use JavaScript. So my suspicion is there probably are a lot of problems there. We just don't hear as much about them.
Yeah, you're more focused on the most heavily used stuff anyway, right?
Yeah.
Now, how do we go about considering the security impact of features at design time? Do we need a red teamer as part of the development team to help drive out defects before we introduce them?
Well, I think it's a good idea to have someone with security experience involved in the design of everything, because there are things you can do at every stage of design to help secure things. So to start off, even when you're thinking about creating a new product, things like, how you split up the components, what language you write it in, that sort of thing can have an impact on security. And also you can start thinking about if there's a really high-risk component, like a parser or something, how you can reduce its privileges, reduce its attack surface, and make it less accessible to attackers. So I think that's an important thing to do as soon as you're starting to think about features. And then as time goes on, it's a good idea to actually have a red team or other team look at the code and actually see if reality matches the way you design the software, and see if there's any defects there.
So you mentioned in your Small is Beautiful talk again that using the same code for multiple purposes can expose it to new and unnecessary attack vectors. I think this is true. Code sharing's sort of a thing that the development community has been trying to sort of do more of for quite a long time, sort of like the high fan-in on pieces of code. So what are your thoughts on, rather than telling developers not to reuse code, we should be trying to help them create more secure pieces of code that can be consumed?
Yes, so the consequences of code sharing are complex. So the specific example I gave in the Small is Beautiful talk is some vulnerabilities I found in a Samsung image decoder. And what happened there is you load the images and then they corrupt memory, and then that can lead to code execution. And the situation was, if you say loaded them in the gallery, this would happen. The problem was the place where this decoding happened, it was in a library called QJPEG, which we looked into, and it turned out that this was actually only used for one thing on the device, which was when you start up your Samsung device and it sings and it has the carrier logo on it and that sort of thing. This image decoder is used to process that image, but it's not used for anything else. But the way they added it to the Android image subsystem was they just plonked it in so that this image decoder was available everywhere, including over the internet. So that's a situation where code was blindly reused and ended up adding a unnecessary attack surface because no one should ever be using this image decoder other than loading a splash screen. But I understand what you're saying. I'm not against code reuse at all, and I think there is a huge security benefit to code reuse in general in that code becomes more mature. But I think the lesson here is just not to plug and play. You need to understand what the shared code does and make sure that you're adding in the smallest amount you need and it's appropriate for the use you're intending it for.
So you also mentioned that multiple copies of the same code can be difficult to maintain. I've noticed that with microservices becoming more hip, this seems to be happening more. Do you have any advice other than pulling the common code out into a separate package and consuming as a library?
Yes, it depends very much on your system. There's a lot of different options here. I think some of the more commonly used libraries do have the option to turn off certain features. And that's a good idea. I think that's actually a very good sign, even when you're selecting which library to use for a certain purpose. If it has flags you can use to limit its exposure, that's very good. And that's a good option. But it depends a lot on what your system looks like. But there's kind of dual problems here. One is if you have too many copies of code and then there's a vuln in it, it can be really hard to find them all and update them. But on the flip side, you can have the problem like the Samsung one. So it's just a trade-off, and it requires evaluating your system and seeing what the best options are.
Can you tell us a bit about the Android Webview issues where several Android features contain their own version of Webview, and the bugs were fixed in one version but not in another?
Yeah, so I was on the Android security team for a while, a couple of years ago, and yes, some vulnerabilities we saw were related to Android web views, which is the part that loads HTML and applications. And there were issues with both internal and external applications bundling web views and then using out-of-date versions. They'd basically sync their own copy of the code and put it into their app and then not update it. So we ended up releasing a unified web view so that now applications can use the system library and there's not the same sort of update problems.
So we're just going to move into a section on third-party code. I discussed this in quite a bit of depth in my own book in the Web Applications chapter of Holistic InfoSec for Web Developers, Physical 1. In your talk, Small is Beautiful again, you mentioned that we should make sure each attack surface only supports needed features, and also that we should be avoiding multiple copies of the same library. These are both concepts that the node packagement ecosystem at least violates. Developers consume huge numbers of packages, even in small projects, often consuming only a package to do one small job. So firstly, for our listeners, can you explain what the problem is here?
Yes, I would say that is something that worries me a fair deal. Yeah, so there's a couple of problems here. One is pulling in the entire package just for one small thing. Of course, it depends on how you use it, but there are certain types of features, like image decoders. You can have a hugely increased attack surface, even if you need it for one thing.
So what happens in the node ecosystem is that a developer will consume a collection of packages, say 5, 10 or whatever, and each of those packages consumes another package, and that might be duplicated from one of your other dependent packages. So they're both consuming the same package but in different places. Yeah, so it just starts to get quite messy.
Yeah, it does. That doesn't quite cause the same concern as, say, having just multiple copies of the same library on a file system, because it does seem like at the very least there's a way to reasonably update them. But I do think it's possible to have problems with something like Node, where since you're pulling in multiple copies of a library, you think you're using only one version, but you're not. But you're actually using two versions, including an outdated version, and that could be a problem. The other thing about this Node thing that concerns me, and it's something else that I mentioned in my talk, is that you should do due diligence on third-party components and make sure they're suitable for the need and that sort of thing. And I feel that a lot of Node projects include, so many components that have dependencies, and their dependencies have dependencies. And it's really hard to know for sure what's actually in a project.
Yeah, there's some pretty good tooling around now that's starting to mature up. So where is the point that you would write something yourself as opposed to actually consuming a library?
I think in general, it's a good idea to use libraries, especially if they're a mature one. For things like, say, SSL or image parsing or anything that's really security high risk, it's almost always a good idea to use a library. The only situation where I would say, it's probably better to write it yourself is if there's no mature libraries. For example, if you're pulling something off of GitHub that you think hardly anyone uses, it's a very good idea, I think, either to write that yourself or make sure that you're very heavily reviewing that code. A lot of the problems that I see with third-party code do come from using these very uncommonly used components that aren't maintained.
You've also mentioned tracking third-party software use and having an internal process that you use, which I've also discussed in my previously mentioned book. Can you explain how you would do this?
Yeah, well, there's lots of different ways to do this, but let me start a little bit with kind of a nightmare scenario that I encountered when working on Project Zero. Tavis Ormindy and I were looking at a FireEye appliance called the Malware Protection System. And basically what this does is this goes through like all your email attachments and that sort of thing and looks for certain types of malware. And we discovered they were using a Java decompiler to decompile any jar files that went over the network interface. And they used a Java decompiler called Jode, which they pulled off the internet, I think, without evaluating, and they used to process these malicious files. And then Tavis contacted the developer, and he said that this decompiler actually executed the code as it decompiles it, and it was completely not suitable for this purpose. So that's a case where this is obviously like a very bad security problem. You send someone an email and it gets executed on this network appliance. And it's an example, I'm not sure what happened there, but it seems like either they weren't keeping good track of what their third-party components were, or they weren't making sure they had the same security boundaries that they needed. So I think a more mature way to do this is to have some sort of internal process for using a third-party component. Basically, more than one person agrees to it. Often you'll need to have a legal review to find out things like, how do they get security fixes? How often will you get updates? That sort of thing, and make sure that that is all suitable for what you need. And then it's a good idea then to have some tracking of versions and vulnerabilities so that if there's a vulnerability found in a third-party component, you can know right away, this is where we use this and this is how we can fix it.
Are you thinking of like tooling as well, like NSP, which is acquired by NPM and Snike, and GitHub have also got like a security scanning system over their repos now?
Yeah, there's quite a few solutions there, and I also know a lot of companies just use internal scripts. But basically, yeah, you need something that feeds into however your projects provide their security updates, and then someone who can monitor them and make sure that they're actually applying all the patches that are needed.
Are there tools that you would like to see automated as part of a DevSecOps process that you think would help the third-party code problems?
Yeah, that's something that I wish existed. I've seen a lot of attempts to make like the perfect tool for this, and I haven't seen something that's, I think 100% of what's needed. But I do wish that there were tools that would make it a lot easier to, in particular, track when components need updates.
Yep, so I think we've already got that in quite a few different tooling solutions, right?
Yeah, I guess what I think the problem is I think for commonly used ones, yes, but it seems like there's always, one straggler that just every time there's a vulnerability, they post to their website at irregular times, and keeping up to date with stuff like that can be difficult.
Yeah. So I'm just thinking in terms of third-party code, are smaller packages an answer or the answer? If so, do we have the package management systems capable of managing really small packages? I mean, how would discoverability work? It's hard enough now trying to find the most suitable package out of 10 that all do the same job, right?
Yeah, so just to be clear here, what do you mean by a small package here? Do you mean a small number of users or a small amount of code?
So a small amount of code.
Yeah, I think that's challenging, and also it really depends on what sort of kind of package manager or method of obtaining third-party code you use. So certainly there are things like Node that use package managers, but there's also a lot of source code repositories, especially ones in C++, where, you're not just automatically fetching packages. You're basically using static libraries or even syncing the code for every library, and that sort of thing has other challenges. But I feel like I don't think package managers is fully the solution here, just because basically so many projects don't use them.
Yeah. So the projects that don't use them, are they mostly compiled languages?
Yeah, I think so.
I'm thinking of your "a puppy is forever" slide in your "small is beautiful" talk. So currently, if we depend on a package that the maintainer isn't keeping patched, we need to fork and maintain it ourselves. Where do you see this ending up?
Yeah, that was a funny slide. So it was actually an Android developer who said that to me. And if you look at how packages are maintained in Android, right, there's no package management. It is, there's the third-party directory, and people copy stuff in there. And the joke he was making is once you copy stuff in there, it's yours forever, and you have to take care of it. Because this is another problem that open source projects have, is they'll use a third-party library and basically not keep it patched and not think about the maintenance of it. So this is true in both forms, that both, if it is maintained, that doesn't mean it's effort free. You still have to make sure you're getting the patches. But then, for every open source project, you need to think about what you're going to do if it gets abandoned. And, that's a very real possibility. And usually this means that either you have to maintain it or you have to, find current users and maintain it as a group or something like that.
Yeah, so I'm working on a reasonably sized project in the moment, and I've had to pretty much inherit 2 to 3 packages because the maintainers have been unresponsive, and basically bring them up to date and weed some bugs out, and then submit the changes back again, and then they've still been unresponsive. So that can be really frustrating, eh? Do you have any ideas on how we can get any better at that?
Yeah, that's challenging. And I think the easiest advice is to think about this before you select the component. That's the easiest time to realize, this isn't being maintained and maybe we should use something else. But, once you pass that point, it can be challenging. I guess you could try your best to contribute. But if you don't have an active maintainer, that's hard. And also, you should count your lucky stars that this is an open source component. It can be even more challenging if, say, you use a closed source component and they go out of business. Yeah, what I've found is there's been 1 or 2 or maybe 3 libraries that does a specific job. I don't have the expertise in that job, so I've had to sort of bite the bullet and just use what's available. And then they've been unresponsive, and then I've had to actually inherit it and basically learn how the thing works and end up fixing it.
Your data is your organization's best asset, but protecting it can feel like your greatest liability. RavenDB is a transactional document database that makes securing your data efficient and simple. You don't need a PhD to use our setup wizard. In minutes, your data cluster is secured with X509 authentication and TLS 1.2 for data on the wire, and with 256-bit encryption for data at rest. Download your free community edition at ravendb.net.
So the Node Security Project, that's NSP, was acquired by NPM on April the 10th this year. And we've got GitHub, which is now providing visibility into the dependencies of their users' repositories and alerting of known security issues if they have a common vulnerability exposure, CVE. Snike provides something similar, but they've been doing this for much longer than GitHub and know of many more issues, like their database is obviously much larger. What are your thoughts on how the open source ecosystem is progressing in terms of creating visibility around defective code?
You have to admit that that's something that I don't know a lot about. I don't spend a lot of time in Node and other package managed language, but that does sound quite promising. And I wish there was more attention to this topic in general.
Have you got any thoughts on how we can do better?
That's a good question. Something I would like is more consistency in how projects put out security updates, because some of them, they do have, very rigorous schedules and that sort of thing. And then there are ones, especially if they don't have security updates very often, they'll just kind of do it randomly or put it on their website. And I think a good first step to making this more manageable would be for projects to more consistently explain how they put out their security updates. And it would even be nice if, say, there was some sort of API or database you could put your updates into so people could query it.
I think NSP actually have that, and that's now part of NPM. I've also noticed that, there was another post recently from NPM stating that now when you install a package from the NPM repository, that you automatically get told whether there are insecurities in it. So that's actually part of the package manager now, which I think is a pretty good initiative.
Yeah, that's a pretty good initiative, but still, this is a much more challenging problem in the non-package managed languages, especially in native code.
Yeah. So I guess that just comes down to talking about it lots and just making people aware of it, and then eventually the people maintaining the packages do something about it.
I think, unfortunately, that's the best option.
Just moving on to a section on developer workflow. In your talk, again, Small is Beautiful, you mentioned that excessive SKUs and branching make it harder to push security updates. They can introduce bugs and can cause incomplete patching. While I think few would disagree with this, a well-defined and sometimes elaborate branching scheme is necessary for larger groups of engineers all collaborating on the same code base. Can you define excessive in this context?
Yeah, so I think actually what I need to define here is branching. So when I'm talking about branching, I don't mean development branching. I mean independently maintained branches. I know it's hard to avoid having lots of development branches, and they can be error prone. It's not as bad as when, say, you have 10 versions of software, or even there are vendors we've worked with who have had thousands of different branches of software that they actually release to different customers, and that's what I think the biggest concern is, the ones that basically having a very large number of release branches is really what causes the most problems.
Yeah, for sure. Can you talk a bit about the CVE 2017-0528? That's the merge error in the Android reducing ASLR bits. What happened with this, and what were the issues that were learned?
This was a fairly surprising bug. Basically, ASLR is address space layout randomization. It's a security feature in most devices. It basically means that memory is allocated at different addresses every time you start an application or start the device. And that makes certain memory corruption vulnerabilities more difficult to exploit. And anyhow, when Android 7.0 was released, the Android team got a bug report that ASLR did not have the right amount of entropy. Memory allocations were not as random as they should be. And they looked into this bug report and found that basically high entropy ASLR had been disabled on this release of Android. And they dug a bit deeper, and it turned out that Qualcomm had released a fix. And to start off, Qualcomm has a lot of branches of their varying software. And then the fixes in all of these branches had to be merged into Android, which also has an extremely large number of branches. And in these many updates that had to be made, there was one error made, which was this specific branch, which was Android 7.0, and this ended up undefining a flag that enabled the ASLR. So this is just an example of maintaining lots of branches is an extremely error-prone process, and I feel like no matter how well you try to do it, if you're trying to merge something into dozens of branches, you're going to mess up eventually.
Yeah, so I think you're talking about orphaned branches semantically, right? Rather than feature branches. Is that correct?
These are still branches that are in use for different versions of Android. It's just there's a lot of them.
They're not feature branches, right?
Yeah, these are release branches. So if you go to say AOSP, you can download, Android 8 or Android 7 or Android 5, and usually 2 or 3 of these are being maintained at different times.
Before the show, you mentioned you also had some anonymized examples of bugs. One was where a vendor failed to patch a security issue due to a complex branching and build system, and their patches were also taking a long time due to this. Can you talk a little bit about that?
Sure. So this is anonymous vendor number 1, and what they did is they forgot to patch a bug, and they told us they'd patched the bug, and then it turned out they hadn't, and we asked what happened, and they said that they have a lot of different software branches, and they also have a lot of different physical devices they make, but the usage of them is very diverse. So, there are things that have, millions of users, and then there's things that have thousands of users, and they're all on this big build tree. And anyhow, what happened is they put in this fix to this issue, and then it has to basically merge through that entire tree into every product. And then they told us they got the fix in, and then a day or so later, one of the builds breaks, and they have to pull the whole thing out. And then there was a communication error where their engineering team forgot to tell the team that was communicating with us. And I mean, that sort of thing happens, but I think the other more important thing that I learned from this is that this build system was basically delaying patches for months. Every time they had this problem and had to pull a patch out, this would, move you to the next patch cycle. And it became pretty clear that having such a complicated build and branching system was making it more difficult to release security patches.
Can you tell us what was actually going on there? I mean, I'm just trying to understand what the situation actually looks like, why they were failing.
Yeah. Unfortunately, I only know what they told me, so my understanding is that they had a few core libraries that a lot of different products used, and that this change was in one of those. And then because that change affects so many different products, it was possible to break things.
So they just missed changing the dependency.
Yeah, pretty much. Yeah, it seems like they must have messed up their change somehow. Yeah, with some strange dependency issue. But what I thought was surprising here was the person I talked to was just complaining about the sheer number and also the amount of time it takes to realize that something has failed.
Can you think of some ways on how you would propose minimal SKUs and branches in a large project where, say, 100 engineers are working on the same code base?
Yeah, so that can be challenging. And as I said, I don't think that the dev branches are a problem. That's a fairly typical dev process. But I think where you really have the problem is providing, say, different branches to different customers that you have to maintain for a long period of time. And what I think the most important thing here is to just realize the true cost of it. I mean, if there's a really big customer that's paying a lot, maybe it's worth doing. But a lot of the vendors I worked with, it was something they did haphazardly without really realizing that you do this once for one customer, it's fine. You do it 1,000 times for 1,000 customers. Now you have to manually put every, patch into 1,000 trees.
Yeah, it's a huge overhead.
Yeah, it's like everything else. I think you need to understand the cost of it, and in particular, things like branching and build systems, I feel like they often get put off to another day, even though they're costing a lot of dev time and quality. And I think it's important to make these things a priority.
Yeah, and the technical debt just builds up.
Yeah.
Yeah, you've talked a little bit about pruning trees regularly and making sure that all code has an owner. Can you explain what you mean by this?
Yeah, so these two things go together. By pruning trees, I mean just make sure all the code that is there is in use. Because it's not uncommon, especially if code doesn't have owners, that there's this old feature that no one has ever used that has bugs in it. And this is even a frequent method that people use to find vulnerabilities. You'll look at code that hasn't been updated recently, because quite often, that's code that was written before we knew a lot about how vulnerabilities worked, and it's less likely that someone has already found vulns in it. So that's one problem. And then making sure code has an owner is just one way to solve this. It's good for security in that if you have a problem, it's always good that all code has an owner, because we have had vendors get back to us and say, oh, we don't think we can fix this bug because we can't find who's responsible for the code. And that's a very bad problem to have in an emergency. But also the joke I always make is if someone owns code, someone wants to get rid of that code and no longer maintain it. And I find that can make dead code get removed a lot more quickly.
Yeah, it's surprisingly common that code doesn't have an owner, especially when defects arise.
Yeah.
So what recommendations do you have for reducing the chances of introducing defects due to branching and merging? I mean, do you have any other ideas or thoughts that we haven't covered?
Yeah, I guess other than don't do it, I don't have a ton of advice. I guess one thing that does help is good testing, and that's how we ended up resolving that Android issue. Unfortunately, like is true in a lot of situations, it wasn't realistic to reduce these branches immediately, but it was possible to add a test for every branch and make sure it gets run on every branch. And this is another problem that comes up, that sometimes we'll find a bug in something and find out that the vendor, has only been, say, testing their new branch, but not the old one, or, ones that, goes out in one locale or not another. So making sure you have really robust testing for every branch can sort of save you from having tons of branches sometimes.
Yeah. So we're just going to move into a section on defects. Keen to talk about the CVE 2017-3558. That's the memory corruption issue in VirtualBox, allowing a guest to host escalation. You mentioned this was due to old code not being fully removed. It was fixed upstream but not downstream. Can you talk a bit about this?
Yeah, so Jan Horn on my team found that bug. And yeah, basically it was due to two problems. One was that this bug had been fixed upstream and not downstream. And since we were just talking about branches, this is another risk that you just forget to fix a bug. And that's what happened here, that someone had branched this code and not fixed it. But then the other slightly amusing thing was that there was a to-do there saying to remove the code, but unfortunately it didn't get to done. And this led to the bug. So, just a reminder to make these sort of things a priority. Thinking about removing the code doesn't help. You need to actually do it, or attackers can use it.
Yeah, that's actually quite common. The branch that you're talking about, was that a release branch or a development branch?
I think it was a release branch. Basically, a different product pulled in this code and didn't keep it up to date.
So can we talk a bit about the CVE 2015-7894? That's the 7 memory corruption issues in the Samsung S6 Edge image processing. So this was due to old, no longer used code being left in the system. Yeah. Can we talk a bit about that?
Yeah, that was the bug I mentioned earlier, where they had the image processor for the splash screen, but they made it available everywhere they processed images. And yeah, that made this bug way, way worse than it had to be.
So what could we have done, or what could they have done so that this didn't happen?
This is one where there's a simple solution, which is they could have put that image decoder somewhere where it only processed the splash screen. Because that's highly privileged code, and if you can change that image, you already have very high access to the device. So that bug itself wasn't the problem. I think if they changed it so that, they just loaded that image decoder in the boot software and nowhere else, they would have solved this problem completely.
Yeah, right. So why was it put in other places as well, do you know?
No, I don't. My guess is simplicity.
Okay, so you mentioned that the following bugs were in the JavaScript engines, not the language JavaScript. Can you tell us a bit about the array.species bug? That's the CVE 2016-7200. That's the issue with array.filter in MS Edge.
Okay. So I've actually found a number of issues in array.species, and just to give a quick background on what array.species is, in JavaScript, you can call a lot of methods on an array. So you can call like array.splice and array.filter. And the question is, so all of these return an array. So if you call this on a subclass of an array, do you get an array back, or do you get the subclass of an array back? And array.species tries to solve this problem by allowing you to override this species symbols to allow you to provide the constructor that will create the thing that is returned by all these array functions. So that's a fairly complicated functionality, and it's led to many vulnerabilities, including this array.filter vulnerability. The problem is, if you think about JavaScript, there's kind of the objects in JavaScript, and then there's the engine that is written in C++, and that has to take the objects from JavaScript and manipulate them. And they don't always look the same under the hood. So most arrays work so that, an array starts its life in JavaScript and you put an integer in it, and then it's an integer array. And then you put, an object in it, then it becomes an object array. And that is a lot bigger because objects are pointers, so they're twice as wide as integers. And then it can get even more complicated. For example, you can make an array read-only, or you can make an element of an array read-only. And basically, the more complicated an array is, the bigger it is in memory. So arrays can get promoted to different types as things happen to them. And what happened with array symbol species is, because you're adding this call to this constructor in the middle of all these sensitive array functions, they could cause array promotion to happen at unexpected times. So I think this array filter issue, it's originally an object array, and then you return an integer array, and then that becomes type confusion. You can read out the pointers as integers, and I think it's also an overflow because the pointers are wider than the integers. But this happened time and time again with this feature where basically you call it, it changes the array, and the developer didn't expect that would happen.
How did it exhibit itself as, or for the engineer, actually writing code on top of it? I mean, what happened for them? What did they see?
Yeah, so this is one of those bugs where, you go to the website and it executes code. So, if you saw this issue without an exploit, it would just look like a crash to you. You would use this code and, you'd get like a seg fault or something like that. But it's something that if a malicious developer uses it, they can make that execute code.
So how did that actually work? Can you give us a bit more details on how you get it to execute your arbitrary code?
Sure. So there's a few different ways you can do this depending on where the memory corruption is. But the general concept is that when you can corrupt memory, you can corrupt things like pointers, and you can change where they point. And sometimes you can even change a pointer to code and make it execute different code. So they have a lot of different features in the memory management of devices these days that make this a lot more difficult. But still, with a lot of effort, you can make it so that by corrupting memory in a very crafted way, you overwrite something, usually in many different stages, that will eventually lead to a pointer to code that you specify being executed.
Yeah, cool. So what was the array index accessor bug? That was the CVE 2017-2447 in Safari's function.bind.
Yeah, that's another interesting bug. And this is another very vulnerable JavaScript feature. And this is what I'm getting at about this attack surface reduction. These are two JavaScript features that I would say don't make JavaScript that much better to end users that led to a very large number of vulnerabilities. And this one is that, believe it or not, in JavaScript, you can put an accessor, so a getter or a setter, on an array index. So you can say, array sub-0, and that'll execute JavaScript. And what's even weirder is there's this thing called prototypes in JavaScript, and this is basically JavaScript inheritance, and if it doesn't find a property, it'll go up to the prototype and check its properties. So you can even add this on an array that doesn't exist yet. You can put this getter or setter on the prototype and then create an array, and then for a completely empty array, do, a sub-0, and that'll execute JavaScript. So this specific Safari bug, this was just unexpected behavior by the JavaScript engine developer. So what happened is in this function bind, which is a function that will basically put default parameters on a function. So you call bind, and it creates this internal array that holds these default parameters. But the engine developer didn't expect that when they create this default array, it could have a getter or setter on it from the prototype. So that's what happens, and then you get a reference to this array that the developer didn't think you could access, and then basically you can change the length unexpectedly, and it'll go out of bounds.
Yeah. So what about the typed array.sort defect in MS Edge? That was the CVE 2.16.7288.
Yeah, this is another feature that's been fairly error prone, and it's something, this is kind of even before I started looking at JavaScript. Many other people found a lot of vulnerabilities in this feature. Although to say something about it, I would say it is a very heavily used and quite useful feature. So typed arrays are arrays that can hold integers and that sort of thing in contiguous memory in JavaScript, and they're often used for performance reasons because, unlike arrays that support array promotion, you can guarantee certain widths and stuff like that, and that has big performance benefits. But they also have this feature detachment, which basically frees the memory and makes the pointer to the array be null. And there's been a lot of problems with this, especially if you think about how JavaScript is not typed. This means if, say, you call typed array.sort, which happened in this case, you have to provide, I think, like an index you start at, and then there's also a function that gets called to compare stuff. And then I think, one of these could call the detach function, and then that caused the memory to be freed, and then you ended up sorting the freed memory. And this one's also interesting in that it was a bug in the standard. So I read through the ECMAScript standard, which is for JavaScript, and it was true that this check was actually missing from the standard. So they wrote it exactly as it was specified, and the memory was freed, and that's exactly what it said. So now the standard's been fixed, so it does say you need to put in an additional check that the memory hasn't been freed before you sort it.
Right, so that's like the most expensive place you can introduce a defect is in your architecture and the specification.
Yeah, it's true. You'd be surprised at how big an impact the specification has on JavaScript. There's this bug, and then there's these two features that represent a very high proportion of bugs in JavaScript, and they even have low usage. So this is just one example of how if you start early and think about your features, they could have prevented a lot of bugs.
Yeah. So that pretty much recovers my next question, which was you mentioned in one of your talks that standards can lead to security issues.
Yeah, I mean, that sounds a little defeatist. Standards can also lead to a lot of security improvements. But yeah, I think like everything else, the design phase is crucial, and deciding what features are worthwhile and how they're going to be designed can determine whether or not there are vulnerabilities. So it's important to keep your features small and simple right from the beginning.
And only do one thing, I guess.
Yeah, well, I'm not against complex features. It's just that these two things, especially that array species, which was fairly difficult to describe, and when you think about it, you're like, when am I ever going to use that? And I think it's like that sort of thing that can really be avoided.
Yeah, right. A low use code. So if there was only one thing you could say to our engineers today, what would it be?
Yeah, I guess just think about your attack surface. You've all heard the joke, oh, it's not a bug, it's a feature. But realize that bugs and features are inextricably linked. Every bug starts its life as features. So if you can start by designing your features well and making sure that they're simple, you can do a lot to improve the security of your software.
Yeah, don't try and be too complicated with your code that you write, I guess.
Yeah.
Do you have any interesting personal projects or events on the go currently?
So I guess I'm continuing to look at browsers. I've currently moved away from JavaScript for the time being, and I'm looking into the new features like WebAssembly and WebRTC, and I think that's pretty cool. And I would go as far to say that I think WebAssembly has done well so far with regards to keeping their feature set small and fairly simple, and as a result, I actually didn't find that many bugs in it.
Yeah, right. So we had a show on WebAssembly. I think it was just the previous show.
Okay.
So thanks for joining us today, Natalie. It's been educational and fun.
Well, thank you.
For Software Engineering Radio, this was Kim Carter.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.